The subsequent video I make on capacitor, I talk about capacitor is defined as the opposition to the flow of current in a given circuit, and it's wrong. That's the formula for resistors. Resistors is defined as opposition to the flow of current in a given circuit. While capacitor is defined as the device that specifically stored a charges in a given circuit. The capacitor is defined as a device or electrical device that stores the charges in a given circuit. Why we talk about resistors? When we say resistors are, resistor is defined as opposition to the flow of current in a given circuit, respectively. And we have, based on this, and the formula for resistors, the SI unit of resistor is always in what? Ohms. It's measured in ohms. And therefore, we talk about the Ohm's law. What is Ohm's law? From the Ohm's law, we have the V is equals to what? IR. Or we said V is proportional to I, equation 1. Remove the proportionality and you put what? R. Equation 2. We have V is equals to IR. So the formula or the Ohm's law says that the potential difference in a given circuit is directly proportional to the current that is flowing in that given circuit, provided temperature remains constant. I'll repeat. The potential difference that flows in a given circuit is directly proportional to the current flowing in a given circuit, provided that temperature remains constant. Or we said the potential difference flow in a given metallic conductor or metallic charges is directly proportional to the quantity of that current that flows through them and the resistors at a constant temperature, respectively. Where we have the V is equals to IR, V is potential difference in volts, I is current in ampere, and R is resistance in ohms. If you are asked to make resistance to the solution of formula, divide by what? I, divide by what? I cancel I. R is equals to V over I, respectively, where potential difference divided by the current, respectively, as the case may be. Also, we have resistors usually affected by temperature. It can also be affected by the length of the wire, respectively. And based on that, we talk about arrangement of resistors. These are symbols of resistors. Oh, this is not symbols of capacitor. The symbols of capacitor is like this. I beg your pardon. Please forgive me. The symbols of capacitor is like this. So these are the symbol of resistors is like this. Resistors, this is resistors arranged in series. Resistors arranged in series, we have this R1, R2, and what? R3 respectively, and the formula is R equivalent is equals to what? R1 plus what? R2 plus what? R3, as the case may be. And these are the resistors arranged in parallel. This R1, R2, and R3 respectively. And based on this, we have 1 over R equivalent is equals to 1 over R1 plus 1 over R2 plus what? 1 over R3 respectively. And let's now see the formula of resistivity. The formula for resistivity is equals to PL over A, because resistance largely depend on the length and depend on the area. And this is the formula for resistivity. This is the rho, this is the length, and this is the area, as the case may be. And this is all about the short note on resistors. And for capacitor, please, I think there's amendment need to be made, which I think is not that much. It's just that these are symbols of capacitor and these symbols of resistors, as the case may be. Thank you so much.